Okay, so I need to give you guys two tricks today. The first one is annuities. Okay, so annuities are a thing about money. And they're the way college savings accounts should work. So let's suppose that your parents were super good to you, and they put $1,000 a year, right, in a 4% interest-bearing account. Right? How much do you have in 17 years? Right? Yeah, let's assume this compounds once a year and that it's actually compounding on the interest that it pays. Okay, so this is not simple interest. Cool?
So wouldn't it be 17 times 1,000 plus 17 times 1.04?
No.
Ah.
Isn't there a formula?
Okay, so the reason we don't do that, that's a good thought though, right? So we do like 17 times 1,000, right? Like that's how much money I deposited, plus, what was your?
1.04 for 4%.
1.04, okay, so that's a 4% increase,
17.
maybe to the 17? Yeah, so I think this would be 4% more of 17, which doesn't make any sense.
Why
right?
wouldn't you do?
The interest should apply to money, right?
Yeah.
So this should maybe be times 1,000.
No, wouldn't
Times
it be
17?
your total of 17 times 1,000? So it's 17,000.
Yeah. So this is 17,000, and you want to put that over here too?
Yeah, there you go.
Yeah. Okay. So problem with this, right, is that the money earned different amounts,
Oh,
right?
Yeah, you were saying it's.
So there's like there's a first $1,000, right?
It
Like-
compounds on the 4% of next year is 2,000.
Okay, so this compounds 4% to 1.04 times 1,000, right? So that's in there. And then there's another 1,000 added. Right, so this is the first year, there's $1,000, and it compounds. So now we're in the second year, right? And in the second year, there's $1,000,
Oh, so they continue.
and also that stuff.
Yeah, and then it compounds on that.
And then all of this stuff, right, gets compounded by 1.04, right? And then there's a new $1,000. Yeah, me too. So you guys see this?
Yeah, I'm wondering what
Right.
my parents were doing.
So the first one, how many times does the first one get interest compounded on it?
17.
Yeah, so the first one gets multiplied by 1.04 to the 17th power. You guys see that? So that's my first one, right? The first one in gets compounded the whole time. The second one gets compounded how many times?
16 times.
Only 16 times. Same interest rate.
Don't you add the difference in between them?
So I'm just envisioning where's this one going, right? All the way down. And where's this one going all the way down? You guys see that? So I'm just thinking I'm thinking about it as 17 different accounts, right? There's the money I put in the first time, that's going to compound. There's the money I put in the second time, that's going to compound. There's the money I put in the third time, that's going to compound. And then I'm just going to add the whatever's in all the accounts together. So I get 1,000 times 1.04 to the 15, and this is going to keep going, right?
Pretty much every 8 years you get an extra $1,000. Every 7.5.
Oh, for the percent
for the interest rate, it gives you $1,000 pretty much.
In 8 years.
7.5 to 8
7
years.
and a half
Yeah.
years. Okay, cool. So
Pretty good.
this money, right, is gonna do that twice, right? So this money will account for how much? How much is that initial $1,000 worth?
You get $40 in interest.
Yeah.
40
Yeah.
For the first year.
for the first year. Yeah. So what's this number actually?
1040.
No, it's 1040 after the first year. What is it total?
One.
If you put the 17 on there.
Oh shit.
20.53.
I'm just doing simple math.
20.53 is what?
I have 1.04 to 17.
No.
I guess my calculator.
Yeah, 1,948.
Let me just double check.
I got 1947.
1.9479.
Yeah. 1947.
Yeah. That's the grand total of that number.
Okay, so this one turns into roughly $2,000, right? So the first $1,000 is worth $2,000 in the end. What's the last $1,000 worth?
$1,000.
Yeah, basically $1,000, right? You guys see that? Okay, so we need a way to figure out how to sum these, and we need to figure out a way to learn how to stop. So where does this thing actually stop?
Well, in this one, the question's a 17, so it's 17 years.
Yeah, so this is actually not well defined here, right? So you need to know whether they put the last payment in or not. You guys see that? The last, like, I don't know what it means by how much in 17 years. So I'm going to assume that that first payment went in and then got compounded 17 times, right? And then I'm going to assume 17 payments, which is going to bring me to what? So 1, 2, what's my last one going to be? It's going to be 1,000 times
1.04 to the 1.
Yeah.
1.04 to 1, right?
Mhm.
You guys all see that?
1,040.
Okay, so that's assuming they got the last payment in, it compounded, and then I'm taking it out.
Yeah.
You guys cool? Before they put the next one in.
Or you're just checking how much you have.
Or I'm just looking to see what I have after that last one compounded. You guys cool? Okay, so I would like to add all these up, right? How in the hell am I going to do that?
Punch in your calculator.
Dear God, no. Don't do that. That's going to take forever.
I got about halfway in about 5 minutes.
Okay, so if we think a little bit harder, this will be a lot easier. So I'm going to notice that's a geometric series. You guys all see that?
Yeah.
Oh, we can do the sum.
Yeah. So that's 1,000, right? Times 1.04 plus 1.04 squared plus yada yada up to plus 1.04
17.
to the 17th. Guys see that?
Mhm.
Okay. So now what was my trick for this? You guys remember the formula, or do you have to develop it every time?
Yeah, the first one, last one.
No, that's the one where they go up by 1 every time. This is geometric, not arithmetic.
A1, R to the n minus 1.
Okay, so you go look up the formula, and you find S is A1 times 1 minus R to the capital N over
1 minus R.
1 minus little r. Okay, so at the very least, I can, out of this guy, eyeball the A1. What's A1?
1,040. Or 1,000.
Oh yeah, I have to remember how that thing works. You guys see that? Crap. So I have to remember whether this started with, like, what was the summation that got me here? You guys remember? I can never remember either. So I just remember the trick. Because I can never remember where this thing frickin' starts. You guys all see that? You all have totally forgotten where this starts, yes? Okay, so just do the trick. So take this whole thing, right? And what do you do? Okay, so you make a new line that's that whole line times minus 1.04. Cool. So you're going to have your 1,000, just chilling, and then you're going to have, let's see, minus 1.04 distributed in. That's going to give me a minus 1.04 squared, and then so on. And then there's going to be a plus minus 1.04 to the 18th power. You guys all see that?
Yeah.
Then what was the point of doing that? Yeah, if you add these, so you call this S, right? And then minus 1.04 S is this graph. And then you add them together. So you get S minus 1.04 S is, and then what cancels there? Yeah, so there's 1,000, right? And then the first term's 1.04
Minus 1.04 to the 18th.
minus 1.04 to the 18th power. So S is 1,000 times 1.04 minus 1.04 to the 18th all over 1 minus 1.04.
Where'd the S go? The second S.
Where'd the second S go? Oh, I thought about this as S times 1 minus 1.04.
Oh, okay.
Right, I factored and then divided it. So you guys get to pick. I don't care which one you do. You can either slam that formula I had here, slam that on a note card with the other thing that it equals, and then sort out the indices. Right, like sort out where the A1 is and what the R is. Or you can just remember how this trick works and do it every time. I don't care.
Basically, you just can't use whatever you want to cancel whatever's inside.
Yeah, you want to make a telescope.
Yeah.
So you're making things fold into each other, right? And then you need to remember to call it something and factor
Okay.
so that you can divide. So you get it here, and then this is some number that you can punch in a calculator, right?
Yeah.
What am I worried about right off the bat here? Just eyeballing this?
If it comes up to 0 on the bottom.
Yeah, 1 minus 1.04 isn't 0, but it is negative, which seems weird. Right?
Oh, you're going to have a negative value.
I have a negative on the bottom. I better make sure that I have a negative on the top too. 1.04 to the 18th is bigger or smaller than 1.04? Bigger, right? Okay, good. So I'm going to get a negative on the top too.
If you get a negative value, what do you do?
Panic.
Because you did something wrong?
Yeah, because the balance in this, right, you've been putting money in this account for 17 years. There better be money in it when you get done.
Yeah, right. Yeah.
Yeah.
Well, I'm talking about like outside of this situation. If you and you plug this in, you have a negative value. You did most likely you did something wrong, right?
I don't know. It might mean something. Like that could mean that you owe money, right?
No, that's true.
So like if you run this whole equation with a mortgage,
Mm-hmm.
you're really paying money into an account, so that outcome should be negative, right? Because you should still owe the bank money.
Right.
What'd you get?
24,645.
That seems kind of reasonable-ish, right? So ballpark, how much should I expect that money to be? Like, what's the rock bottom that money should be?
$17,000.
Yeah, it damn well better be more than 17,000 bucks, right? Do I think it's going to be $35,000?
4%, no.
Yeah, it's 4% interest. I mean, it's been in there a while, but it's probably not going to double.
If you left it in there for double the amount of time, you'd get a lot more.
Yeah, if I left it in there a lot longer, right, I would get a lot more money out of it.
So
Doesn't
plan
it
ahead
take
for you get a child.
Oh, no, more each side.
Yeah.
Yeah, so this grows not quite exponentially, actually grows a little bit better. So exponential, right, means that the growth rate is proportional to the amount. That's satisfied just by compound interest. Compound interest grows exponentially anyway. This is actually a little better because I'm not only getting growth proportional to the amount, I'm also getting additional growth. You guys see that?
Mm-hmm.